we obtained Segotep's newly released 3200W titanium-rated silicon carbide digital power supply. This unit follows the standard CRPS form factor and adopts a fully digital control solution from Texas Instruments. It integrates two digital signal processor chips, one dedicated to interleave Totem-Pole power factor correction control and the other for full-bridge LLC control. The model designation is CRPS 3200W 12V, and it supports a wide input voltage range. The front side of the metal case has a label. AC input, 100 to 127 volts alternating current, 16 amps, 50 or 60 Hz. DC output, plus 12.2 volts, 123 amps, plus 12 volts standby 3 amps. Maximum output power, 1500 watts. AC input, 200 to 220 volts alternating current, 16 amps, 50 or 60 Hz. DC output, plus 12.2 volts, 245.9 amps, plus 12 volts standby 3 amps. Maximum output power, 3000 watts. AC input, 220 to 240 volts alternating current, 16 amps, 50 or 60 Hz. DC output, plus 12.2 volts, 262.3 amps, plus 12 volts standby 3 amps. Maximum output power, 3200 watts. DC input, 240 volts direct current, 16 amps. DC output, plus 12.2 volts, 262.3 amps, plus 12 volts standby 3 amps. Maximum output power, 3200 watts. The springs on the front side are used for grounding. Springs are also provided on the rear side. The side is equipped with latches and screws. The input side is equipped with a handle, cooling fan, input socket, power indicator, and release lever. The fan guard is labeled with 3200 watts, titanium, and CRPS. The input socket is AC20 type. Close-up of the light-emitting diode indicator light. The output side features a grill and a Goldfinger printed circuit board. The length of the module is about 199.6 millimeters, 7.86 inches. The width is about 73.5 millimeters, 2.89 inches. The thickness is about 38.9 millimeters, 1.53 inches. That's how big it is in the hand. The weight is about 979 grams, 34.53 ounces. Next, let's take it apart to see its internal components and structure. Unscrew the screws to remove the housing. Copper foil inside the housing is used for shielding. The printed circuit board assembly, PCBA, module is wrapped in black mylar for insulation and secured with tape. A thermal pad is placed at the opening. The thermal pad corresponds to the small printed circuit boards. Close-up of the connectors for the cooling fan, indicator light, and current transformer. The input socket is insulated with a mylar sheet. The socket is connected via wires. The PCB for driving LLC metal oxide semiconductor field effect transistors, MOSFETs, is connected to the control PCB via a ribbon cable. The input wires are connected by soldering. Unscrew the screws and remove the PCBA module. The mylar sheet is secured with double-sided adhesive tape. Close-up of the ribbon cable. The light-emitting diode indicator is insulated with a heat shrink tube. The cooling fan has fixed blades. Close-up of the C20 input socket. The back of the socket is equipped with blue-white capacitors and a safety X2 capacitor. The safety X2 capacitor is from electromagnetic fields, EMF, with a specification of 1.2 microfarads. The front side of the PCBA module contains components such as a fuse, common mode choke, safety X2 capacitor, Totem-Pole power factor correction MOSFET, power factor correction boost inductor, LLC MOSFET, high voltage filter capacitor, LLC resonant inductor, LLC transformer, solid capacitors, and other related components. The back side contains a current sensing chip, power factor correction controller, isolation communication chip, and other components. Remove the power factor correction MOSFET printed circuit board, LLC MOSFET printed circuit board, standby power PCB, LLC control PCB, high voltage filter capacitor, and output transformer. The input fuse is insulated with a heat shrink tube. The common mode choke is wound with enameled wire, with a varistor and a current sensing resistor installed at the bottom. The varistor is from JOIN, model 14S471K, used to absorb overvoltage surges. Two 0.5 milliohm sensing resistors are connected in parallel to measure the input current. The safety X2 capacitor is from EMF, with a specification of 1 microfarad. Another safety X2 capacitor is from NDF, with a specification of 1.8 microfarads. The blue Y capacitors are from Murata. These two blue Y capacitors are from NDF. The power factor correction controller is from Texas Instruments, model TMS320F280039CQ1. It features a built-in C28X digital signal processor core and an integrated programmable control law accelerator, with a main frequency of 120 MHz, 384 KB of flash, and 69 KB of random access memory. It includes high-performance analog modules and offers 16 pulse width modulation channels. The controller supports PM-bus, inter-integrated circuit, controller area network, serial peripheral interface, serial communication interface, local interconnect network, and flexible serial interface interfaces, configurable logic blocks, and a host interface controller. It comes in an LQFP100 package. The filter capacitor is from Chemet, with a specification of 100 microfarads, 25 volts. The Synchronous buck chip is from Texas Instruments, model TPS560430X3F. It supports an input voltage of 4 to 36 volts, outputs 3.3 volts at 600 mA, operates at a switching frequency of 1.1 MHz in forced pulse width modulation mode, and comes in a SOT23 package. The operational amplifier chip is from Texas Instruments, model TLV9001. It is a single-channel, rail-to-rail input and output operational amplifier, supporting an operating voltage range of 1.85 to 5.5 volts, and comes in a SOT23 package. Another operational amplifier has the same model. Close-up of the chip marked WB9M. The digital isolation chip is from Texas Instruments, model ISO7841. It is an enhanced 4-channel digital isolator, supporting a 100 megabits per second data rate, and comes in a 16-pin small outline integrated circuit package. The two Totem-Pole MOSFET printed circuit boards have identical appearances and are each composed of two PCBs joined together by soldering. One of the PCBs is equipped with an isolated power supply and an isolated driver. The other PCB is equipped with MOSFETs and diodes, with soldered copper plates added to enhance heat dissipation. The two PCBs are connected via pin headers. The front side of the driver PCB is soldered with two isolated drivers, two isolation transformers, and a power supply chip. The back side of the PCB has no components. The isolated driver is from Novasense, model NSI6602V. It is the second-generation high-reliability isolated dual-channel gate driver, featuring 6 amps source current, 8 amps sync current, a typical propagation delay of 25 nanoseconds, and comes in an SOP16 package. The Synchronous buck chip is from Texas Instruments, model TPS62933F. It is a synchronous step-down converter supporting an input voltage of 3.8 to 30 volts and an output voltage range of 0.8 to 22 volts. The chip integrates internal MOSFETs, supports a continuous output current of 3 amps, and comes in a SOT583 package. Close-up of the isolation transformers. This PCB has 4 PFC MOSFETs. The backside has copper strips to enhance current carrying capacity, soldered copper plates to increase heat dissipation area, and diodes for auxiliary rectification. The two silicon carbide MOSFETs on the left are from Infineon, marked 65 or 083M1, model IMD65 or 083M1H, with a voltage rating of 650 volts, an on resistance of 83 milliohms, and come in an HSOF8 package. The two MOSFETs on the right are also from Infineon, marked 60 or 040S7, model IPT60 or 040S7. They are NMOS devices with a voltage rating of 650 volts, an on resistance of 45 milliohms, and come in an HSOF8 package. The two diodes are from Diodes, model S8KC, rated at 800 volts, 8 amps, and come in an SMC package. The PFC boost inductor is wound with enameled wire, with a Bakelite insulating board at the bottom and secured with adhesive. The backside of the PCBA module has two diodes of the same model. Close-up of the other diode. The current sensing chip is from Allergo, model ACS37010. It features a 450 kHz bandwidth and high-precision current measurement, supports an operating temperature range of -40 degrees Celsius to 150 degrees Celsius, and comes in an SOIC6 package. Another current sensing chip has the same model and is used to measure the currents of the two Totem-Pole PFC inductors. The thermistor is from Thinking, model TKSPI500, used to suppress inrush current during power on. The relay is from Songchuan, model 103-1AHC, with a single normally open contact and a 12-volt coil voltage. The SMD fuse is used for LLC-level overcurrent protection, with a rating of 20 amps. The high-voltage filter capacitor is insulated with wrap tape. It is from Rubicon, part of the MXD series of ultra-compact electrolytic capacitors, with a rating of 450 volts, 1200 microfarads. The MLCC capacitors are connected in parallel with the high-voltage filter capacitor. The LLC controller and op-amp are located on the front of the LLC control PCB. The backside houses the memory, op-amp, and synchronous buck chip. The LLC controller is from Texas Instruments, TI, model TMS320F280039CQ1, the same model as the PFC controller. The memory is from Microchip, marked with 5LAZ, model 25LC160C, with a capacity of 2 kilobytes, supports an operating voltage range of 2.5 to 5.5 volts, and uses a TSSOP package. The memory is from Microchip, marked with 02C, model at 24C02C, with a capacity of 256 bytes, supports an operating voltage range of 1.7 to 5.5 volts, and uses a TSSOP package. The synchronous buck chip uses the TI TPS560430X3F. The op-amp is from TI, marked with BUQ, model OPA376, which is a precision low-quiescent current op-amp that supports rail-to-rail input and output and uses an SOT23 package. Close-up of the op-amp marked with 2904. The op-amp is from TI, marked with 28BB, model LM2904B, an industry-standard dual operational amplifier in a VSSOP8 package. The op-amp is from TI, marked with OVLM, model OPA2192, which is a low offset voltage, low input bias current, rail-to-rail input and output precision operational amplifier with excellent DC precision and AC performance, and is packaged in VSSOP8. The voltage reference is from TI, marked with Y3HJ, model TLV431B, with a reference voltage of 1.24 volts, a tolerance of 0.5%, and is packaged in an SOT23-5. The op-amp is from TI, model TLV9001. Close-up of the connectors of the current transformer and indicator light. Close-up of the reserved connector. Close-up of the connector for the PCB of the LLC MOSFETs. The PCB of LLC MOSFETs consists of two PCBs. The copper sheets on the back are used to enhance heat dissipation. Separate the two PCBs, which are connected via pin headers. There are isolation drivers, an isolation transformer, and a power chip on the front of the driver PCB. There are no components on the back. The drivers for the LLC MOSFETs are from Novasense, model NSI6602BD. The chip has a built-in isolated dual-channel gate driver with 4 amp source current and 6 amp sync current capability, and is packaged in an SOW16 package. The synchronous buck chip uses TI TPS62933F. Close-up of the isolation transformer. Close-up of the cable socket connected to the control PCB. The front of this PCB has 4 LLC MOSFETs forming a full bridge LLC, and the right side has resonant capacitors and a current transformer. The copper sheets on the back enhance heat dissipation. The LLC MOSFETs are from Infineon, marked with 60 or 045F7, model IPT60 or 045CFD7, NMOS, with a withstand voltage of 650 volts, a resistance of 45 milliohms, and are packaged in an HSOF8 package. The NPO resonant capacitors are packaged in 1210. There is also a resonant capacitor on the back. The current transformer is wound with multi-layer insulated wire. The resonant inductor is wound with Litz wire. The output end is equipped with a standby power supply PCB, LLC control PCB, solid capacitors, and synchronous rectification PCB. This is the synchronous rectification PCB. The primary winding of the transformer is wound with multi-layer insulated wire, while the secondary winding is manufactured using planar transformer technology. The transformer uses a PQ35 magnetic core and is insulated with high-temperature tape. The output features 6 synchronous rectifier PCBs to evenly distribute heat. One side of the PCB is equipped with the synchronous rectifiers, driver, MLCC capacitors, and filter inductor. The other side is also equipped with synchronous rectifiers, a driver, and MLCC capacitors. The synchronous rectifiers are from Infineon, model ISC015N04NM5, NMOS, with a withstand voltage of 40 volts, a resistance of 1.5 milliohms, and are packaged in a TDSON8FL. There is also a synchronous rectifier of the same model on the other side. The driver is from TI, model UCC27517. It is a single-channel, high-speed low-side gate driver, supporting an operating voltage of 4.5 to 18 volts. It features 4 amps peak source and sync current, rail-to-rail drive capability, and comes in an SOT23 package. Another synchronous rectifier of the same model. There are 2 synchronous rectifiers of the same model on the back. The driver uses TI UCC27517. The MLCC capacitors are packaged in 1206, with 10 connected in parallel. There are also 10 MLCC capacitors on the other side. Close-up of the 0.1 microhenry filter inductor. The capacitors for output filtering are soldered on vertical PCBs. The capacitors are from NCC and are PSG series conductive polymer solid aluminum electrolytic capacitors with a specification of 2700 microfarads 16 volts. The output control MOSFETs are from Infineon, marked 006E2C5, model IQE006NE2LM5CG. They are NMOS devices with a voltage rating of 25 volts and an on resistance of 0.65 milliohms, packaged in a TTFN 9-1 package. 9 1 sense resistors are connected in parallel to measure the output current. The PCB interlayers also accommodate the output control MOSFETs and the current sense resistors. The interlayer contains 6 output control MOSFETs and 9 current sense resistors. The operational amplifier is from TI, marked OUIS, model OPA192. It is a precision op-amp with low offset voltage, low input bias current, and rail-to-rail input and output, packaged in SOD23. The ideal diode controller is from TI, marked SCHB, model LM5050. It supports an operating voltage of 5 to 75 volts and comes in a SOT23 package. The standby power supply PCB is composed of 2 PCBs soldered together. The opposite side contains capacitors. Upon separating the 2 PCBs, a mylar sheet was found between them for insulation. The outer side of the standby power supply PCB houses the standby power chip, synchronous buck chip, feedback optocoupler, and synchronous rectifier. The opposite side features a fuse, an isolation transformer, optocouplers, and a synchronous rectifier controller. The fuse is rated at 1 amp. The TVS diode is from Panjit, marked EWF, model P6SMB250A. It has a working voltage of 214 volts and comes in an SMB package. The standby power chip is from Infineon, model IC5AR0680AG. It integrates an 800-volt, 0.71 ohm MOSFET, operates at a switching frequency of 100 kHz, supports a wide input voltage range with 40 watts output power, and comes in a DSO12 package. The planar transformer uses an EQ25 magnetic core. The synchronous buck chip is a TI TPS62933F. Close-up of the isolation transformer. Close-up of the MLCC filter capacitors. Close-up of the Everlight EL1018 optocoupler. The other optocoupler has the same model. The synchronous rectifier controller is from MPS, marked IAZ, model MP6908. It supports high-side and low-side synchronous rectification without an auxiliary winding, features built-in ringing detection, and is compatible with synchronous rectifiers using standard or logic level voltages. It supports DCM, CCM, and QR operating modes and comes in a TSOT23-6 package. The synchronous rectifier is from Toshiba, model TPH8R80ANH. It is an NMOS device with a voltage rating of 100 volts and an on resistance of 7.4 milliohms, packaged in an SOP advanced package. Close-up of MLCC filter capacitors. The other PCB features filter capacitors and a load switch. The backside has no components. The filter capacitors are from Capexon, part of the PM series of solid capacitors, with a rating of 180 microfarads, 16 volts. The load switch is from TI, model TPS2594828A. It supports an operating voltage range of 3.5 to 23 volts, features a built-in 12.2 milliohms protection FET, supports an 8 amps operating current, and comes in a PWCSP12 package. The current sense amplifier is from TI, marked OBX, model INA213. It is a 26 volts bidirectional high-precision current sense amplifier compliant with the AEC Q100 standard, packaged in SC70. The ideal diode is from TI, marked 2AEH, model LM73100. It features reverse polarity and overvoltage protection, supports an operating voltage range of 2.7 to 23 volts, includes a 28.4 milliohms internal FET, supports a 5.5 amps operating current, and comes in a QFN10 package. Close-up of an SMD fuse marked with T. Close-up of the 1.5 microhenry alloy inductor. The Schottky diode is from Panjit, model SK54BLF, rated 40 volts, 5 amps, and comes in an SMBF package. Close-up of the socket for connecting the cooling fan. Well, those are all components of the Segotep 3200W titanium-rated SiC digital server power supply.